We are back working on the museum piece, Bvm F100. Let's dive right into the action. Thanks for tuning in, guys. Subscribe if you're not subscribed. Let's go. Last video, lots of blah, blah, blah. This video, lots of doing. We've got a bunch of our servos already cycled. We're also working on the Rebel Hot project as well too. So the Rebel Hot servos are being cycled right now. So we're gonna get into servo swapping. So basically we just essentially get these servos laid out the same way. This servo here, we're gonna have to add a little bit of wood because our new servos are a little bit different dimensions. But having your radio set up is important during this phase because this is when you're getting your servos, your movement. I mean, obviously we're adjusting that movement later on, but for example, your tail hook, it's gonna start off here, move that direction. The chute mechanism is gonna start off here, move that direction to lock it. So you wanna be able to set those things up. So as we put these servos in place, we're gonna leave all the leads and everything loose. And then once those leads are, or once the servos are switched and we're happy with everything, then we'll start running the servos. We're gonna have an ashlock plug here. So we've got how many things going on? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's one 12-pin connector. We've got the rudder servo. So we've got the tail section moved up on our bench here. I'm gonna set up this is my test receiver or setup receiver for the shop. Rex 12 missing its plug-in ends. I've eventually cut those off is how that got to that point. But you can still power this with a servo plug. So anyways, this is what we're gonna bind to the radio program, which will allow us to get things set up. If we did have the Central Box 310 series here, at this point I would actually plug the receiver into the Central Box and use that. But because we don't have the Central Box here, I'll just use the Rex 12. And if we do need to rearrange any channels, we'll just use like port number 1 as an example in the radio. If we need to make 16 temporarily to port number 1 so we can set it up, that's what we'll do. So the goal here is to reuse all of the hardware as long as it's in good shape. Initially taking a look at it, it all looks like it's in great shape, so that's the plan. Obviously the servo arms we cannot reuse because these are all JR servos. So what I'll do is initially here is I'm just going to start to get these servos taken out as a first step. So I'm not just going to do them one at a time. I'm going to take everything out and then we'll start from square one. So once we get all these servos out, we'll do these 2 smaller servos, I think, first. All right, elevator servos are out and they're here. It's pretty funny going through this plane and just seeing, how things were run back then. Of course, you had a matchbox and these guys were plugged into the matchbox. One of the servos was reversed. It's awesome because you're so limited with channels. So anyways, that stuff is now removed from the plane. And as we go through this, we will be upgrading certain things. So in a scenario like this, the previous arm was the JR heavy duty arm. These things are awesome. They're actually great arms. There's nothing wrong with nylon arms. Like here's the MKS nylon arm right there. So we could use this one as basically a direct replacement, but on something like the horizontal stabs on this plane, we want to go a little bit above and beyond because it's probably better. So what we're going to switch these guys out with is the MKS carbon short arms. These are great for clevises, also good for ball joints too, but they're nice and thick and they work really well. The other thing I like about them is the hole pattern doesn't usually line up with the stock servo arms, which is great because what I do is I'll drill out my own holes and we'll drill them out to match these previous JR arms and everything will drop in perfectly. So it'll be a little bit further out than the close hole right there. All right, and as a cat owner, this is kind of how we spend a lot of our time working here in the shop. When she's not sleeping, she wants to be here. It's nice in the cold months though. She keeps my neck warm. Okay, so switching these horns out, what I do is take a 3mm bolt and that allows me to install the stock setup over top of the MKS setup. and then we take our 1/16 drill bit, which is the perfect size for the clevis hole. It's nice and tight, and we drill that out. So we've done that on both of these guys. You can see there our second hole that we've added. So now we're going to sand these arms down to be basically at the base of the factory hole right at the end of my finger. The nice thing about these arms, we do have these listed on our website in sort of limited quantities. The nice thing about these arms is the brass piece that mounts on the servo. If you find that this is not mounting at perfectly 90 degrees, you can take the arm off, rotate the brass piece, and generally I find one of those three locations is bang on perfect. And this arm fits on 3 different ways on that brass piece. So there is a little bit of glue on there from the factory, but it does pop off quite nicely. All right, so servos are set up. One thing to keep in mind is when you're putting the servos in, I thought about this after the fact, but when you're putting the servos in, obviously they're reversed, right? Because left is here, right is there. So I know that's a small thing, but it does matter. So when I put these servos in, I made sure that this is my left one, which is port number 4. This is my right one, which is port number 5. So just something to keep in mind. So we'll put our screws in place now using Loctite. Those are all squared off and beautiful looking. And these are basically ready to go in the aircraft. All right, so our mount for the tail hook servo, we had to open that up a little bit. So you can see there, we sanded that out with the Dremel. The 747 servo is a little bit wider than the one that came out, which is why we need to open that up a little bit. So the servo arm that came off there was the small JR one. We basically took one of these small MKS ones and made one of those. So the holes match up perfectly. So that should work good. This tail hook in this aircraft uses very small amounts of movement to make that work. So it's not going to take much at all. So we still need to drill our holes to get our servo mounted, but we're going to get that done pretty quick. And what we need to do is we need to get the radio on, which it's on. We need to get the servo plugged in, centered, and we really will probably just set it up on a switch and just to get the actual movement set up here, probably one of our back switches back there. All right, so this is one of those scenarios where we want to make one of our ports on our Rex 12 to be what we need it to be. So you can see here our tail hook is assigned to 20. Well, there obviously is not a port 20 on the Rex 12, so we're going to go through assigning this. So we're going to use port number 1 as our assignable port, or that's the one we're going to manipulate. So we've got the Rex 12 plugged in. So we'll escape out of here to the main menu. We're going to go to Model, Device Explorer, Rex 12. So we'll go to Receiver Outputs, and we're going to take output pin number 1, which is currently throttle, which is number 1, and we are going to make this number 20. So now if we take this servo, plug it into port number 1, there we go. It should operate with our rear right-hand switch, which it does. So now we can go in and we can narrow those endpoints down so that, because it's a two-way switch right now, that operates at -100 plus 100. So we're just going to go into our model, servo setup, servo number 20, tail hook, and we'll narrow this way down. So we'll say 10%, 10%, and now when we make that switch moving, the arm basically moves, or the servo shaft moves almost nothing. So what this is doing is we're going to get our center set up, and then we can just adjust those endpoints. So we can get that arm installed on the servo. Actually, what we'll probably do is we'll get this arm installed on the clevis first, and then the position on here will be determined by the actual positioning of the existing arm and everything. So that will be that'll be good. So our positive side is our closed direction. So we'll just keep the switch in the closed direction. All right, so we got our tail hook hooked up here. I'll give you the rundown of the inside once we're done everything, but we've got that adjusted and set up on our back switch. So I just set it up so it retracts quick and then comes down nice and slow. Tail skid, I think, is actually what it is. All right, so we've got both of our accessory servos mounted and done. This is the chute servo. I had to add an extra piece of support back there, so basically just custom shaped that, and now it is nice and solid. Previously that servo was mounted here, and now we're mounted on both edges, of course. The servo movement when this opens is towards us, and it doesn't move very much, but it's just enough to disengage those pins in the back, and that's the actual servo channel itself. So -29 to +29, and it works. Initially, I just set that up on the same switch as our tail skid. So that is our SM switch in the back. And so now when I do that SM switch, both the skid and the chute are both active. Just for setup, there's going to be some logical switches and stuff used, but we need something to set this guy up. So with those two servos done, I'm going to move on to our vertical stab servo. So I'm going to leave the horizontal stab servos to the end because I want to get our stabs reinstalled and get the servos installed and then hook these guys up to the servos. So it makes sense to get that vertical stab one done next. So that one should be fairly straightforward, I think. We've got our golden clevises there, and basically we'll just be matching that as best as possible. All right, so we got our rudder servo set up here. We got new clevises installed. We needed to just cut the old arm and undo these old clevises because they had a bit of high sol or aero epoxy holding them together. So anyways, that gives us an opportunity to put new clevises on there. Just put the 9930 servo in, and it is not sitting down all the way because it's touching the fuselage right there. So we need to install one of our wooden spacers here. So the old servo had the rubbers on them. So we're not going to be using the rubbers. So in its place, we will install the servo spacer, which should, there we go, bring it out properly. The other one too was sitting out a little bit further because of the rubbers that were used. So anyways, the rudder is a little difficult to work on, of course, but as far as access goes, but it's a little bit nicer because you've got more adjustment with it, which is actually quite handy. So one of the challenges with this aircraft is just working on it and being careful. Like, you know, the flight metal is in general very delicate. So we are just being careful. Like I don't know if it's showing up in the camera, but there's a blanket on the ground and or on the workbench, and that blanket just helps to keep it all in good shape. Okay, so these Phillips servo screws I'm not having much love for, so I'm going to take them out. These are the ones that come with the servos. I'm going to take them out and switch them with some Allen key ones. There we go. Much better. So one of the things we'll do in this scenario is we're going to get the servo screwed in, and then we're going to wick some thin CA into the wood and servo screws and everything. So we'll just put some thin CA right here on the front and back, and that ensures that the screws are locked, the wood's locked, everything's locked in place, and make for a nice solid setup. All right, servo is all installed. We've got our rudder linkages hooked up. Nice thing about starting fresh here is you get to start over, right? And make everything nice and tight and snug. And these lines here before, cables, had a little bit of play in them before, and like slack, and now we've got them nice and tight. And that's naturally going to happen over time. Those cables, I mean, they've been sitting for a long time. And now everything is nice and snug. We've got everything nice and centered, so perfection. So getting those stabs back on was definitely a lesson in patience, but they're done. I just checked the current new manual, and it says the neutral is 1/4 inches down from this panel line right here. So that's where we're going to base it off of. Kind of looks like it's appropriate because we're going to get our little U shape for the stab to move. We're going to get a little bit more up travel than we do down travel, which is sort of typical. So, and these panel lines that were done in the flight metal were the panel lines that were on the fuselage, at least from what I could see when I fixed that other stab. So we're going to get our servos installed now for the horizontal stab and see how that works out. And stab servos are in and working awesome. So they're perfectly balanced in the center. We will eventually get our endpoints balanced as well too using the jetty radio. It's nice to have the central box when you do that because you can get the amperage output on the screen and you can see if these things are interfering with each other. So we will work on that a little bit later on once the central box shows up. But yeah, so that worked out good. One thing I'll do in this stage is get our travels adjusted. So on a setup like this, the manual calls for 1.75 inches. So this is leading edge measurement, so up elevator. So 1.7 inches this way, 1.25 inches, so 1.25 inches down. So I've got those things set up, and that is using the servo endpoints. So they're going to be fixed endpoints, and then we can use the dual rate menu for different flight modes, but that's what it looks like. And this setup here is absolutely rock solid. Zero play in this setup, which is exactly what we're after. So very happy with that. That turned out wonderful. Need to put my little keepers on there, and all of our servos in the back end are complete. All right, so with our back end servos completed, we still need to deal with our heat shielding on certain items, but I've been spending a bit of time on the pipe. Now, if you watch the decommissioning video, the previous pipe was set up a little bit different. So the original BVM pipe, you had the inner pipe with like a zigzag thing, and then you had the outer pipe, which is completely separate. So in that scenario, the outer pipe actually got screwed to the back of the fuselage, and you could slip the inner pipe in from the fuselage. So the way I've designed this pipe was made by Scott from Elite Aerosports. The way I designed this pipe was, it's pretty much the same dimensions, but it's all one piece. So what happens is this pipe now can get slipped in from the back of the fuselage, butts into the bypass, and then these straps here, which we haven't sized or drilled yet, they will fasten to the bypass. So all the mounting is the same. It's just the design of it is going to be a little bit different. So I've been spending a bit of time getting some dimensions and everything mocked up just to make sure we're going to be correct and everything's in the right wheelhouse and everything looks good. So that's why the intake duct and the bypass are currently inside the fuselage. So anyways, that's good. That's positive. So we've got a clear path going forward with the pipe. Now back to the servos. So we need to do a little bit of heat shielding here. Not much. There's basically two important things that get close to the pipe. All of these servos down here they're spaced out very nicely. So we're going to leave all those. This top servo, because obviously heat rises, and we've got a nylon arm here on the pull setup, we're going to put some heat shielding across this. So we're just going to use some ceramic blanket that we took out of the plane previously and just put a layer across like this, and we will silicone that in place. So it's basically just going to make a shield or a blanket. And the other thing is the chute assembly back there. So that is plastic, I believe, and we want to put a layer of the heat shield material, the ceramic blanket, over top of that, because the outer layer of the pipe does almost come in contact with that. Now, one thing to remember is because we're changing the way this is designed, there's going to be a lot better flow through with air in this scenario. So generally, with a properly designed system, those outer layers, the pipe outer layers, they stay quite cool compared to the inner pipe layers. So just something to be aware of, but it's nice to have a clear path going forward. All right, so our top heat shielding is done. So what I did was I took some of that ceramic blanket, covered it with our foil tape and 2 layers on both sides. And then we put some shoe goop on each side of the foil piece. And then we held it in place with some tape and then just sealed off the edges of the tape so the tape doesn't come off with some shoe goop. And then our cable is up top here for our rudder servo. That's just tucked in under another piece of tape, and that comes down to this side right here. So I'm not 100% sure yet. I think what I'll do is I will probably do all of our leads on this one side right here. Reason for that is the way things kind of were designed previously. All of the servo leads come down this side of the fuselage. So we'll possibly keep it that way. I mean, obviously our fuel tanks are here, our electronics and everything are going to go in this area, but underneath the ducting system. So we'll see how things go. But on this back end, it really doesn't matter where we come through. So I'm just going to continue running these servo leads to this location right here. So we've got all of our wire leads run to this one location. I decided to go just to that one location. So we're going to do one 3-pin 9-pin ash lock connector and one 6-pin ash lock connector because we've got 5 servo leads. So now we're going to cover up our chute holder with some heat shield. All right, so we got our little piece of heat shield installed on the chute mechanism there. I used some shoe goop to hold that in place, molded it to the shape of it. And then we've got our connector leads done up here as well too. So those are all marked and they're done with the female connector. And we've got some spiral wrap installed over the wires just to protect it as they rub against the fuselage there. So back end is now complete and ready to join to the front when the front is ready. So I think the last thing to do to get the back end all prepared is I want to get our intake duct bypass pipe all set up and spaced out properly. So first thing I'm going to do is I'm going to get our bypass set up on our pipe, I think is the first option. Our first thing to do, and that involves getting our straps at the front of the pipe sized and drilled for our holes. So that is in my brain what I think we need to do first. Then we'll get it all assembled in the aircraft. So the intake duct, the bypass, we'll screw the bypass down, get the back end installed on the aircraft, get the pipe installed in the aircraft, make sure our tail cone is spaced and everything, or exhaust nozzle, turkey feathers, whatever you want to call it. Make sure that's all spaced properly, and then I'll be happy to continue moving forward. So front duct is installed, bypass is installed. That goes together very well. So what we'll do now is we'll put the back end of the fuselage on, lightly fasten it down, and then our pipe assembly gets inserted from the back of the fuselage. This is where stuff can get tricky or it can be easy depending on how we did getting this set up. And I think, without jinxing it, okay. All right, so the straps aren't bad. They just kind of slip beside the bypass. Nice. Wow, that's lucky. And then access for our pipe straps, I think is going to be through the gear openings, is going to be the easiest, yes. So the hardest part about all of this is just getting the pipe aligned, but should go together nicely, I think. So what I'm actually doing here is I'm adjusting the the depth of everything, because that pipe is sitting inside the tail cone, and we've got an extra spacer around the back end. So the original pipe design basically had like a fiberglass piece, this metal piece, and then the pipe was on the inside. We've gone a little bit bigger on the pipe size, got rid of the fiberglass piece, kept the metal piece, which is our kind of our extender slash adjuster, and we've got the pipe. Right now the pipe is sitting about here, so we can push it forward a little bit, but it's just a matter of getting it all aligned. That's the key. So it's going to be a little bit tricky, I think, but we'll see. All right, so we've got our pipe put in place. It's not screwed down yet, but our holes are lined up, which is awesome. And that's what the back end looks like there. So that is great. We don't have that screwed in yet. Basically what I wanted to make sure was that our distance with our pipe and everything lines up, and now we've got everything set. So that was kind of the key. I was going to get our turbine sort of mocked up. The original straps are way too big. These fit around the turbine, and there's just a ton of space, so we're not going to use those guys. So we will include these with that AMT engine. Again, if you're interested in that AMT engine, these straps will come with the engine because we'll be using hose clamps. Now, these hose clamps, they're a 4-inch hose clamp. 91 to 114 millimeters. They're a little bit too small, so we need to get some 5-inch hose clamps, but that's what we're going to be using to mount the turbine. So can't get it mocked up right now. We can probably lay the turbine in the base of the bypass with a spacer underneath, like some layers of foam, and that'll allow us to see how things are going to sit. So just did a quick little mock-up here with the 240, and that is going to fit beautifully in this aircraft. So it's not centered right now up and down in the pipe, so it's actually got to drop a little bit further. I just have maybe a 2-cell lipo underneath that engine right now. But yeah, dimension-wise, that is wicked. It's smaller than the Olympus that came out of here, the AMT engine, but the nice thing is the pipe spacing is really good. So we've got a decent pipe spacing back there. We are basically centered on our turbine mounting straps, which is wonderful. We can go a little bit further back actually, but yeah, just for a rough mock-up, that is exactly what I wanted to see. So that is very good. I'm happy with that, very happy. All right, guys, with that big step accomplished, now it's time to disassemble or dismantle those things. So we'll pull the engine out, pull the pipe out, and pull the bypass out, pull the duct out, pull the tail off, and then we'll continue on with our installation / removal. All right, well, I had some West Systems mixed up. Some 610, this is the thick stuff, the aero epoxy. I did a patch here on the duct. This is where the duct had some contact or whatever. I think it's been like that for a long time because it wasn't like it was just impacted, it was actually like molded. So we did that repair. I just put a bunch of West Systems 610 on there, piece of carbon cloth, smoothed it all out. That is basically going to be pretty much hidden when that's done. And then the other thing I'll do here is we've got a little bit of repair to do on this mount right there. So we'll just get some epoxy pushed in there, and that will hopefully fix up that mounting bracket. All right, so we're just cycling the last of the servos, and it's time to move into the fuselage. So we still need to take a bunch of this stuff out. So all of our things that we can take out, we are going to take out. You know, things like this, if we can get that out, we're going to take it out. So, but all of our wire clips and everything are coming out. Now, one of the things when setting up the flap servos, that's the next servos we have to go to, is if we take that servo arm right there, push it all the way against the wing mount, and I look down the side of the fuselage, our flap's actually going up. So all I'm doing is lining that up with our wing. You can see there's some holes in the side of the fuselage anyways, so I'm just lining that flap up so it's horizontal. and that gives me an idea of how much space we have between the actuation arm and this plate. So we don't need to set it up so it's tight. It needs to be spaced off just a little bit. So, and that tells us how we need to set everything up as far as the servos go. So we're pretty much going to use the exact same setup here. Yeah, so, and then full flaps are obviously coming towards us this way, but the servo arm doesn't really move that much. So flap servos should be fairly easy to set up, I think. So what we need to do is we need to dismantle this stuff back here. I'm probably just going to take the linkage off the servo end, leave it connected to the actuation arm because that all looks good. All right, so we got the back end of the aircraft cleaned up where the flaps go, and we're going to get the flaps set up. So initially, the JR servos were using the nylon arm, the heavy-duty nylon arm. And we're going to change things up a little bit just because there's some funky geometry going on. Not crazy, but we're going to use some aluminum KST arms. And we're going to put a ball joint on the servo end. That's going to allow a little bit of flexibility and movement and make things a little bit better, I think. So anyways, the KST arms, we just need to get these servos plugged into our receiver. So generally when I'm doing flaps like this, I want to always get the flaps set up outside of the aircraft. Now, this is a nice servo setup because there's no mechanical lock. So when this is off or zero flaps, we're in this kind of spot here. When the flaps are on, we're kind of in that spot right there. So there's no mechanical lock, there's nothing like that that gets our geometry. So it's all servo position based, which is totally fine. So that's how we're going to get things set up. So I'm going to get my receiver plugged into my radio. We'll get both of these flap servos installed into the receiver, and then we'll be able to set these guys up independently, but also at the same time, so our movements are going to be very close. All right, so we powered up our receiver. We'll just go into our menu, and our flaps are 6 and 7. So 6 is left, 7 is right. So we're going to take our servos, plug them in. So now we'll just confirm they're going the correct direction.
Take off flight mode 1.
And they are. So now what I do is I go into my servo menu and I just kind of make some numbers here and make sure that we're actually going to get enough travel. So, okay, so what I want to do here is I want to get this set up so we've got a little bit of headroom built in. So we're going to go minus 20, we'll go minus 30,
full flaps,
and then we'll go minus 40.
Take off flight mode 1. Take off full flaps.
There we go.
Flight mode 1.
So now we've got a little bit of adjustment room in all directions to get the flap set up. So now with flaps off, we'll get our arms installed relatively matching. So just taking a guess here on kind of location, we were sort of not parallel, but something like that.
2 minutes.
So what I'll do too is I'm going to take this and just put it in the plane and kind of see how close we are before we get too crazy. All right, so that was a really close spot right there. What I'll do next too is I'm going to take a ball joint that we're going to use and I'm going to check against the golden clevis and see how that distance is affected. Our ball joints are basically the same dimension as the golden clevis, so that is a great position. All right, so we're pretty close there as far as matching goes. Again, doesn't really matter on this setup because it is using servo position to get this installed. And then just to give you an idea of what this looks like, so that is flaps off, take off flaps, full flaps. And again, we're just putting some random numbers and positions in here. Those need to be adjusted when they're in the aircraft. And I'll probably dial them down because I don't want to go too far where you're damaging something. There we go. So now we're flaps off, take off flaps, full flaps. Maybe need to do more travel, but those don't matter right now. So we'll get these screwed down and of course using Loctite. All right, so flap, servos, and linkages and everything are installed. Turned out very well. I'm happy with everything, how it's laid out. One thing with the ball joints is we threaded them in all the way. The clevises were a lot longer before, so now our arm is almost actually mechanically locked at flaps off, which is good. So we've got a little bit more headroom to adjust that, but there's a random spot for takeoff and full flaps. And there's a shot of the linkage on the side. There we go. Well, pulled, this is obviously, I'm being sarcastic, but pulled about 5 pounds of holders and Velcro out of the fuselage. That was about an hour and a half of sanding, grinding, pulling, prying. Anyways, so almost all of the crap is out of the fuselage as far as holders go. We still have a bunch of things to remove, like our air cylinders, and I'm going to try and take this stuff out as well too, because we don't need a lot of that, and we've got to start with a clean slate. So, whew. And you know, just for giggles, I'm actually curious to see how much this stuff weighs that we pulled out. So let's weigh this, and we'll dump it out and then weigh the container. So this is, I think it's going to be kind of funny. So 113 grams. $28 grams. That's funny. Almost a quarter pound of weight in holders and Velcro. All right, guys, and that's going to wrap up video 3 in the series of the museum piece, the Bvm F100 aircraft. So far, happy with everything. The control surfaces were probably the easiest portion. The most difficult portion for me right now is the organizing and the cleaning and how to fit everything in here. That's really the struggle for me. We've made some big leaps with getting the back end done, the bypass and everything sorted out too. That's wonderful. So, not really sure next video where we're going to continue on. It's just going to be continuing with cleaning up the fuselage. I think I'm going to spend some time in the next video figuring out how we're going to make a servo operated air brake as well too. So hopefully we can figure that out. That's the plan. So that's it for this video. In the next video, we'll do the draw for the giveaway from the previous video, the little package for the turbine install kit that Joe from RC Custom 3D Printing provided. So keep an eye out for that in video number 3. If you missed that or don't know what I'm talking about, go back, hit the playlist down below, watch video number 2. We're doing a giveaway in that video. So if this is well in the future, the giveaway's already happened. All right, guys, that's everything. Thanks so much for watching and supporting the channel. We'll see you in the next video.